Dear students, welcome back. Today we are going to discuss the cases of the lines in auxiliary vertical plane, auxiliary inclined plane and profile plane. Here we can see auxiliary inclined plane is the plane which is inclined to horizontal plane at an angle alpha and it is perpendicular to vertical plane as shown in figure. An observer looking from the front can see the elevation of this plane on vertical plane. If the line AB is contained in the auxiliary inclined plane and an observer looking from the front side can see the A dash B dash on the vertical plane which is at an inclination alpha. So the inclination of the auxiliary inclined plane and the elevation of the line A dash B dash will be same because the line AB is in the auxiliary inclined plane. Similarly, if the line is on auxiliary vertical plane, that is the plane which is inclined at an angle beta with vertical plane and perpendicular to horizontal plane. If another line PQ is contained in the vertical plane, an observer looking from the top can see the plan of the line PQ on horizontal plane and we can see the plan PQ of the line will be inclined at an angle beta which is exactly equal to the inclination of auxiliary vertical plane. That is, the inclination of auxiliary vertical plane with VP is equal to the inclination of top view PQ with XY line. Clear? Now we can check the horizontal and vertical traces in the case of line in the profile plane. That is, here we know A dash B dash the elevation and AB the plan are obtained on the same vertical projector. The side view A double dash B double dash shows the true length of the line. The sum of inclinations theta plus phi will be 90 degree. Now I am going to extend the line A double dash B double dash to get it intersected on the XY line. Now I get this intersecting point and that will be the H double dash, which is the side view of the horizontal trace. Similarly, if I am extending this line and get it intersected with this vertical line, I will get the point V double dash, which is the side view of the vertical trace. Now I have to get the projections of this horizontal trace and vertical trace to this vertical projector. For that I have to bring the H double dash to the horizontal plane and get it intersected with the vertical projector and get the point HT. Similarly, I can project the V double dash towards the vertical projector of A dash B dash and get this intersecting point. That point will be the vertical trace VT. As I mentioned before, both V and H dash will be on the XY line. So In this case, V and H dash will be at this intersecting point, and it is marked as H dash and V. H dash is the front view of the horizontal trace and V is the plan of the vertical trace. Now we can solve the problems related to this concept. Here, a line AB 80 mm long makes 30-degree angle with horizontal plane and lies in an auxiliary vertical plane 45-degree inclined to vertical plane. And A is 15 mm above horizontal plane and vertical trace is 10 mm below XY line. Draw projections, find angle with vertical plane and horizontal trace. Here, the inclination of auxiliary vertical plane is given as 45 degree. We have to consider this inclination of auxiliary vertical plane as the inclination of top view of our line. We have to start the solution from XY line, draw a vertical projector and mark the location of vertical trace, which is 10 mm below XY line. So 10 mm below we can mark vertical trace and point V on XY line, which is the plan of vertical trace. Now we have the position of end A, which is 15 mm above horizontal plane. So 15 mm above XY line we can draw the locus line of A dash. Now we have the inclination of line AB with horizontal plane, that is theta is equal to 30 degree. So I am going to mark 30 degree from VT and draw a line. We can consider the 45 degree as the beta, that is the inclination of plan of the line. So I am going to draw a line which is 45 degree inclined through point V, like this. We have the line which passing through VT at an inclination theta, which means this line represents the true length line. So this intersecting point is one end of the true length line, which can be marked as A1 dash. From A1 dash I can mark the true length of the line, which is given as 80 mm. So I am marking 80 mm from here and getting the endpoint B1 dash. Now I can have the locus line for B dash. Now I am drawing a vertical projector from this B1 dash and rotating to get the intersecting point B, which is the plan of the endpoint B. Now I can draw a vertical projector through B, which will intersect here, that will be the point B dash. Now I can join VT B dash and get the point A dash on the locus line of A dash and A1 dash. Now this A dash B dash is the front view and this intersecting point represents point A and AB will be the plan of the line. Now I can rotate this elevation and made it horizontal like this, and then I can drop it down to get the point B1. Now I can join VB1 like this. Now the inclination of this line VB1 with XY line will be the inclination phi, which is the inclination of line with vertical plane. Now this point of intersection of line B dash A dash VT with XY line represents H dash and corresponding point on the vertical projector which intersects with the plane line will be HT. Now our solution is over. The next problem is a line AB 75 millimeter long has one end A in vertical plane, other end B is 15 millimeter above horizontal plane and 50 millimeter in front of vertical plane. Draw the projections of the line when sum of its inclinations with horizontal plane and vertical plane is 90 degree. Here the sum of the inclinations with horizontal plane and vertical plane is 90 degree means theta plus phi is 90 degree, which means it is lying in a profile plane. You are asked to find the true angles with reference planes and its traces. We can solve this problem like this. Start with the XY line. We can mark point A on XY line and other end B is 15 millimeter above horizontal plane and 50 millimeter in front of vertical plane. Since theta plus phi is 90 degree, all these projections will be on the same vertical projector. To draw the side view, we have to draw a vertical line which represents the vertical plane in the side view at a convenient distance from this single vertical projector which contains plan and elevation. Now we know the point B is 15 millimeter above horizontal plane. So B dash will be 15 millimeter above XY line and it is 50 millimeter in front of vertical plane. So the point B will be 50 millimeter below XY line. Now we can draw the horizontal projectors. B is projected in the upward direction and the intersecting point will be B double dash. We have the true length of the line 75 millimeter and given that the end A is in the vertical plane. Here this is the vertical plane and this is the horizontal plane. B double dash as center, you can cut an arc of 75 millimeter long in the vertical plane. Now this intersecting point will be A double dash, which is the side view of the point A. A double dash. Now I can extend the line to get it intersected with horizontal plane and that point will be H double dash. Here we can see A double dash and V double dash are on the same point because the line penetrates the vertical plane at this point itself. Now we can project A double dash and V double dash to the vertical projector and we will get A dash and VT. Similarly, H double dash is projected downward and get it intersected with the common projector and that point will be the horizontal trace. Now the actual inclinations theta and phi can be measured from this side view. Now the solution is over. Thank you.